morning students. I am Rama Devi, working as a chemistry faculty in Target English Medium School. Today I am going to explain about the Test-1 question paper and the answers explanation for 10th class students. Now, first I explain about the half mark questions, then 1, 2 and 4 marks questions. Already you know the question paper, you wrote well also, I know about the question and answers papers. Yes, see, once we have to go through the half mark questions. They are asking the first question is, hematite is an iron ore and bauxite is an aluminium ore. Hematite is an iron ore, bauxite is an aluminium ore. Yes, both are correct answers. So, for first question, option C the answer. Option C, both are correct. Because hematite is an iron ore, yes, and bauxite is an aluminium ore. Both are correct options. For next question, in the following questions, which one is the alkane? Which one is the alkane? Okay, they are given the formulas and we find the alkane. A, C2H5, B, C2H6, C, C3H8, D, C3H6. In out of these formulas, we have to find the alkane. We know the alkane general formula, that is alkane general formula is CnH2n plus 2. You have to apply the number here by the following formula. Here 2 is there, means you can apply 2, C2, H 2 into 2 plus 2 and equals to C2H6. So this is not alkane. At the same number C2 is there, is also there. So C2H6, yes, it is the alkane C2H6. Then go for the third number, n is equals to 3 value. Yes, C3, H 2 into 3 plus 2, that equals to C3, H8. 2 3 is 6, 6 plus 2, 8. So this is also a alkane. So option B and option C both are correct answers for finding the alkane. Are you understand, students? And go for fourth option, C3H6 is there. If carbon number is the 3, must be the hydrogen number is 8 in the alkanes. In the only alkanes. This is the general formula for only alkanes. What is that? Cn H2n plus 2. Here n is the number of value. We get number. For example, in the A option, 2 number is there for carbon. So 2 number I applied here, C2 H2 into 2 plus 2. Total the value is C2H6. So this is not the correct answer. Here B is the correct option. At the same time, option 3 substitute the 3 number C3 H2 into 3 plus 2. We get the value is C3H8. So this is the correct option. But this is not the correct option. So for second question, what are the alkanes means? Option B and C, that is C2H6 and C3H8. That is the second question. You must be remember for the alkanes general formula CnH2n plus 2. Yes. That is the second question. They are given 3 test tubes. In these test tubes, iron rays they are given and asked the question is, in the first test tube, rusty iron rays are appeared. The question is, in the first test tube, rusty iron rays are appeared. Why and what is the reason? Or which materials are presented in the first test tube they are asking. Okay, so indirectly also ask why, what is the reason. Okay, why? Because in the first test tube the reason is, third question answer, air and water both are available. Are you understand? In the first test tube, why rusty iron nails are appeared means in the first test tube, air and water both are available in the test tube. That's why the iron nails are get easily rusted. We know already rusting of iron nails is the mainly caused by the air and the water. We know already all of you that the process is also called corrosion. Okay, not only iron, any metal get exposed to air and water, it will become converted into corroded. Okay, that is the third question option, air and water. You write only air and water also correct answer. That is the third question. Next, fourth question. Saturated hydrocarbon. In the following, they are given some names. In that, we have find the saturated hydrocarbon. What are saturated hydrocarbons? Alkanes are called saturated hydrocarbon. Alkanes are called saturated hydrocarbon. Alkane, a compound is a must be nothing but saturated hydrocarbon. Here, in the they are given the following compounds are pentane, pentene, pentyne. Pentane, pentene, pentyne. So, in these three, which is the saturated hydrocarbon? We know all of us. Pentane. What is the option? A. Pentane. If you know A is nothing but it is a saturated hydrocarbon. If E and I are there, both are unsaturated hydrocarbons. Are you understand? So what is the saturated hydrocarbon? Pentane. Pent plus N, pentane. Yes. Question. Write any two p block elements. Write any two p block elements. Any two p block elements you have to write them. No problem. Any two p block elements, oxygen, chlorine, third A, fourth A, fifth A, sixth A, seventh A group elements are nothing but p block elements. We have to write any element in the third A to seventh A group, no problem. Of course, 8th A also we have to write, but 8th A is also called stable group or zero group elements. Separately it was divided. That's why we have to must be remember. If they are asking in write any two p block elements or anything means you have to write up to third A to 7th A group elements. Okay. That is fourth and fifth question. Oxygen, chlorine, boron, carbon, nitrogen. These are all belongs to only p block elements. You have to write any element. Next. Coming into next to half mark question, sixth question. They are given this diagram in the question only. They are asking the question is, in this experiment, the bulb was glows in the presence of which solutions? They are given the options. A. Glucose, B. Alcohol, C. Hydrochloric acid, that is HCl, D. Sulfuric acid, that is H2SO4, that is H2SO4. Are you understand? They are given the diagram and they are given the options. They are asking question. In the above diagram or in the above experiment, the bulb glows in the presence of which solutions? They are given option A. Glucose, B. Alcohol, C. Hydrochloric acid, D. Sulfuric acid. The formula is H2SO4. Yes, we know already. In the presence of which solution the bulb was glows means in the presence of acidic solutions. In out of these four options, though which are acidic solutions? Hydrochloric acid and sulfuric acid. Option 3 and 4, that is option C and D. Option 3 and 4 are the correct answers for this question because in the presence of acidic solution, the bulb was glows. Glucose is not a acidic solution. Alcohol is not a acidic solution. Are you understand? Yes. These are the half mark questions. Next, coming into 1 mark questions. question is, give examples of ionic and covalent compounds. These are 1 mark questions, madam. Yes. Give examples for ionic and covalent compounds. Yes. Next is 7th question. Give examples for ionic. We know ionic compounds means must be the cation and anions are comes to close together to form the ionic compounds. For example, sodium chloride. The formula is NaCl. Ionic compounds. Calcium chloride. The formula is CaCl2. Not only for sodium and calcium, aluminum chloride, magnesium oxide, sodium oxide. These are examples for the ionic compounds. Next, covalent compounds. We know covalent compounds are nothing but by sharing of electrons, those are formed. Oxygen molecule, that is O2, N2, Cl2, and etc. These are examples for covalent compounds. Methane is also example for covalent compounds. Must we have to write for ionic compounds 2 examples, for covalent compounds 2 examples. Okay? Yes. Next question. Why do some atoms are combined together, but why others do not? Why do some atoms are combined together, while other atoms are do not? You understand the question meaning? Why some atoms are, while others do not? Because based on the stability concept, we are explaining the answer for this question. Based on stability concept. Okay. What is that? The atoms which have 8 electrons in their outer shell or 2 electrons in their outer shell are already stable. Those atoms do not combine together. Okay, means stable elements are not combined together. Unstable elements are only combined together. Okay, so unstable elements or unstable atoms are only combined together because they get stability. Not involved in the bond formation because already they are stable elements by getting the 8 electrons in their outermost shell. Okay, simply you have to write the answer for this question. The atoms which have 8 electrons in their outer shell are not combined together. Atoms which have lesser than 8 or lesser than 2 electrons, those atoms are combined together and involved in the bond formation for getting stability. For getting stability, you have to remember stable elements are not participated in the bond formation. Unstable elements are in the bond formation. Okay, Nana? Yes. That is the answer for 1 mark. Next, 9th question. The densities of calcium and barium are 1.55 and 3.51. See, this is the question. The densities of calcium and barium are 1.55 and 3.51 gram centimeter cube. Based on the Daubermire law of triads, can you give the approximate density of the strontium? Can you give the approximate density of the strontium? Next question, that is 9th question here. What are the densities of calcium? Calcium density is 1.55 and the barium density is 3.51. This is their given data. Yes. They are asking, according to the Daubermire law of triad, we have to calculate the average density of the strontium. Strontium, yes sir. We know, according to Daubermire law of triad, we know what is the law of triad. The first and last element average atomic weight is equals to the middle element atomic weight. The first and last element average atomic weight is equals to the middle element atomic weight. Based on same law, we are applicable here also. The two average densities of the calcium and barium is equals to the strontium density. Is equals to the strontium density. Means what is the calcium density? 1.55. It is equals to 1.55 plus. What is the barium? 3.51 by 2. 3.51 by 2. Okay? Yes. See there. What is the value? 1.55 plus 3.51 by 2. We are calculating that one. We are getting the final value is 2.53. We are getting the final value is 2.53. We now see here. 5, 1, 6, 5, 5, 10, 3, 1, 4, 5. 5.06. That is 5.06 by 2. 2 2s are. Then 4. 2 5s are. Then 2 3s are. What is the value? 2.53. So what is the average density of the strontium means 2.53. How we get this value means we have to sum the calcium density and barium density and doing by 2. That is the Davarnir law of triad. The first and last element average atomic weight is equals to the middle element atomic weight. Calcium, strontium, barium. These are three elements which are follow the Davarnir law. That is, we are calling Davarnir law of triad. These are triad in a Davarnir law. One of the triad, calcium, strontium, barium. That is the value 2.53 for strontium. If you approximately you are in the 2.6 also, no problem. Next, last question in the 1 mark. What is catenation? Long chain formation. Simply you have to write long chain formation. Okay. Long chain formation. The property is known as the catenation. How the long chain is formed? By self-linking of the carbon atoms. By self-linking of the carbon atoms. Means when carbon atoms are self-linking together to produce the long chain molecules, this property is known as catenation. You simply remember long chain formation is known as catenation by self-linking of carbon atoms. By self-linking of carbon atoms. That is called catenation. So these are 1 mark questions and half mark questions. Now we are going to explain about the 2 marks questions. Once you have to see the first question. They are given the ml values. Those are -2, -1, 0, +1 and +2. They are asking the 2 questions in this. First question is name the subshell and second question is what is the maximum number of electrons can be accommodated in the given subshell. The first question is name the subshell. They are given the ml values are -2. They are starting the value is a 2. Okay. So we know already L value 0 for s orbital, L value is 1 for p, L value is a 2 for d, L value is a 3 for f. You remember L value is a 2 for d. So they are starting the ml values are -2, -1, 0, +1, +2. Okay. So total we get the ml values are 5. Based on this information we get the idea the L value is a 2 for D subshell. So what is the answer? Name of the subshell is D. That is the first question answer. And second question answer. What are the maximum number of electrons accommodated in the given subshell? The given subshell. What is the maximum capacity of electrons? Okay. So you know already in the d orbital how many electrons are filled? 10 electrons. If you forget this, you apply the formula 2n square. 2 into 2 square. If the n value for d N values are starting from 1, 2, 3. Okay, yes. 2 square. 2 2s are sorry. Not the maximum capacity of electrons in the orbitals this formula. Sorry. So now with this, you get the value from L is equals to 2 means that is the subshell D. We know in the D subshell how many electrons are filled means 10 electrons. We know the maximum capacity of D electrons is D subshell is 10 electrons. In the S only 2, in the P 6 electrons, in the D 10 electrons, in the F 14 electrons. Okay. That is the 2 marks questions, first one. Next, second question. Give examples for acids and bases. Give examples for acids and bases. You have to write any examples for acids. Sulfuric acid, hydrochloric acid. And for the bases, sodium hydroxide, calcium hydroxide. Sodium carbonate is a mild base. I think most of the you have to write the sodium carbonate. But you remember sodium carbonate is a base. Okay. Sodium hydroxide, calcium hydroxide, barium hydroxide, magnesium hydroxide. These are examples of the bases. Yes. Next, repeat question. Why do valency electrons are only involved in bond formation? Why cannot inner shell electrons are not involved in the bond formation? Why do valency electrons are only involved in the bond formation? For example, I was taken the sodium atomic number 11. This is the nucleus K, L, M. In the M, 1 electron is there. In the L, 8 electrons are there. In the K, 2 electrons are there. 1s2, 2s2, 2p6, 3s2. Yes. This is the outer shell. Outer electron, this one. These are inner shell electrons. Inner electrons. What is the question? Why do valency electrons are only involved in the bond formation? Why cannot inner shell electrons are not involved in the bond formation? Because we have to observe the K and the L both are inner shell electrons. The M, this is the K, L, M. M is the outer electron. This M shell is the outer shell. Which is the near to nucleus? The K and the L shells are near to the nucleus. But the M is far away from the nucleus. Yes, the nucleus is strongly attracted the K and the L. The nucleus force upon the K and the L are very strong. But the nucleus force upon the M shell is negligible. Somewhat negligible. Not very strong. Okay. So, the outer shell electrons are loosely interacted with the nucleus. That's why those are get easily point. The outer shell electrons are not get affected by the the outer shell electrons are not get affected by the nucleus. The inner shell electrons are very severely affected by the nucleus. Nothing but same attracted the inner shell electrons. The shell is far away from it. That's why the nucleus force is less on the outer shell. At the same time outer electrons. But the nucleus force is more on the inner shells at the same time inner electrons. So the outer shells are strongly affected, they are weakly affected by the nucleus. The inner shell electrons are strongly affected by the nucleus. That's why these are easily escaped and involved in the bond formation. That is the answer for next question for 2 marks. Okay. Next. Formation of N2 molecule according to the Lewis theory. You understand? Lewis theory means dotted method. Okay. VBT means diagram method. Okay. Yes. VBT means valency bond theory. Yes. You see nitrogen N. Atomic number 7, electronic configuration 1s2, 2s2, 2p3. In outer shell, how many electrons are there? 5 electrons. Nitrogen, 5 electrons are there. 1, 2, 3, 4, 5. Another nitrogen, 1, 2, 3, 4, 5. When both nitrogen atoms are comes to close together, those are shared the electrons between together. How many electrons are sharing together means for one nitrogen 3 electrons, for another nitrogen 3 electrons. Those are sharing. See the 1, 2, 3. Nitrogen 1, 2. Yes. These 3 electrons from this nitrogen and to produce the triple bond. To produce the triple bond. Okay. Like this, you have to draw the diagram and write the matter. Nitrogen atom, atomic number 7, electronic configuration 1s2, 2s2, 2p3. In outer shell, each nitrogen has 5 electrons. In out of 5, 3 electrons donating each other and produce the triple bond, sharing the 6 electrons by the 2 nitrogen atoms to produce the triple bond, that is N, triple bond N. These one pair of electrons still present at the apex of the nitrogen atoms. This is according to Lewis theory. We explain the formation of N2 molecule. Explain the formation of N2 molecule. Yes. These are the 2 marks questions. Next, we are going to explain about the 4 marks. Yes. Now I am going to explain about the 4 marks questions. First question is Cole's rule. Explain with examples. Most of the members you write only one example, but in the main exams must be remember you have to write the 2 examples at least. You write the first rule, then explain the rule with taking by taking anything, either carbon, nitrogen, oxygen, any 2 examples you have to take and explain those 2 examples. Otherwise, you lose the marks. What is the Hooke's rule? Yes, the rule is nothing but, Hooke's rule is nothing but electron pairing is done in the orbitals when all the available empty orbitals which have the same energy must be singly occupied. Singly occupied. Otherwise, you remember simply the degenerated orbitals must be singly occupied. Then after electron pairing is done in the remaining orbitals. Remaining orbitals. This law is known as Hooke's rule. So what is the rule? Electron pairing is done in available empty degenerated orbitals must be singly occupied. Must be singly occupied. Then after pairing is possible. Yes, by taking of 2 examples, I explain this rule. One is carbon, symbol C, atomic number 6, electronic configuration 1s2, 2s2, 2p2. 2p2 means 2px1, 2py1, 2pz0. Yes. See the electronic configuration. 2px1, 2py1, 2px1 1, 2py1 1, 2pz0 not there in electrons. See, in the P there are 3 suborbitals, that is 2px, 2py, 2pz. These are called degenerated orbitals, means which have equal energy. Which have equal energy. Yes, when these available empty degenerated orbitals are there, these orbitals must be singly occupied. Then after pairing is possible. Pairing is possible. What I can say here means 2p2 means 2s2, 2p2. Here 2p2 means those 2 electrons not presented in the 2px only. Must be 2px1, 2py1. 2p z also 1. If all available empty orbitals are singly occupied, then after pairing is possible. For example, we have to see one more example. Example 1, example 2. I am taking the oxygen, symbol O, atomic number 8, electronic configuration 1s2, 2s2, 2p4. See here, L, 1s2, 2s2, 2p4, 2px1, 2py1, 2pz1, then 3 completed, 4. If pairing is possible after the singly occupied orbitals with each one electron, then after pairing is possible. This is the statement of Moore's rule. Are you understand? Yes, I have taken the carbon and oxygen 2 examples. Carbon atomic number 6 and the electronic configuration is 1s2, 2s2, 2p2. Yes, I am filling the electrons in these orbitals. 2p2 means in 2px1 in 2py1. Not 2 electrons are presented in the 2px only. That is the wrong according to the empty orbital is must be singly occupied. Then after pairing is possible. We will go for oxygen. At the same time 1s2, 2s2, 2p4. Here 4 electrons are there. So each one is singly occupied. 2px1, 2py1, 2pz1. Then after one more electron is paired in the 2px. Then after if 2p5 is there, one more electron. If 2p6 is there, one more electron. Like this, the pairing is possible in the degenerated orbitals according to the Moore's rule. Yes. This is the statement. And same in this internal choice question. Write the differences between valence. Differences means you must be draw a table and write at least for 4 marks you have to write at least 5 points. Okay. If you okay, that is better. We know already for this question answer number of times we have to explain in the class rules also. Valence and covalency differences. What are valency electrons? The electrons presented in the outer shell. The electrons presented in the outer shell. The electrons presented in the outer shell are known as valency electrons. You know the point. What is the covalency of the element? Covalency, nothing but the electrons which are shared in the bonding is known as covalency. The electrons which are shared in the bonding or bond formation is known as covalency of that particular element. The electrons which are presented in the outer shell orbitals which are readily participated in the bonding, is also known as covalency of the element. Which are participating in the bonding. Okay. For example, covalency. Na atomic number 11. The number of valence electrons are 1. Okay, means that one 1s2, 2s2, 2p6, 3s1. Okay, L, M. The electrons which are presented in the outer shell, that number is nothing but valency electron number. Covalency for fluorine 17 atomic number 1s2, 2s2, 2p6, 3s2, 3p5, K, L, M. This is the outer shell. 7 valency electrons are there, but the covalency of chlorine is 1. Why? Because it was ready to get participated in the bonding by taking off 1 electron. Covalency of the chlorine element is 1. Okay, yes. The valency electron number is always positive. Means 1, 2, 3, 4, 5, 6 like that only up to 7. The covalency number is either positive or negative. You write one more example for valency electrons. For example, like any carbon or nitrogen or like that. Or you have to write one more example for covalency, that is anything boron and hydrogen or anything. For hydrogen, covalency is also 1. The valence electron number is also 1. Okay, that is the differences between valency electrons and covalency. Covalency in the notebook also I simply given. You have to follow that data. This is the next question in the 4 marks. They are given the table. Observe the information given below it. The first question is, write the L value and the symbol of the spherical shaped subshell. Write the L value and the symbol of the spherical shaped subshell. What is the spherical shaped subshell? S orbital is the spherical shaped subshell. What is the L value for spherical shaped subshell? That is for S. L value is a 0. What is the first question? Write the L value and the symbol of the spherical shaped subshell. Write the L value. L value is a 0 for spherical shaped subshell. First question answer. The spherical shaped subshell is S orbital. The L value for S is 0. What is the symbol? S orbital. The L value is a 0. Okay. Second question. What are the how many values that ml takes for L is equals to 2? There, see. If L value 2, how many ml values will come? That is the question. This is the answer. What is the question? Second question. How many values that ml takes for L is equals to 2? L value is 2. L value 2 means how many ml values can you say? 5. Minus 2, minus 1, 0, plus 1, plus 2. So how many ml values will come for L value is equals to 2? 5. What are they? Minus 2, minus 1, 0, plus 1, plus 2. That is the second question. Now coming into third. Write the symbols of the orbitals for L is equals to 1. If L is equals to 0, the S orbital. If L is equals to 1, that is the P orbital. Write the symbol. Write the symbols for orbitals L is equals to 1. That is which one? P orbital. What is next question? Fourth one. What is the shape of the subshell for L is equals to 2? What is the shape of the subshell for L is equals to 2? For L is equals to 2, how many ml? This one. What is the shape of the subshell? What is the orbital attached? That one D subshell. What is the shape? Double dumbbell. What is the shape? Double dumbbell. Next, in the same question, what is the maximum number of electrons that can occupy this subshell? Means 10 electrons. How many are there? 10 electrons. Okay? Yes. For the first question, spherical shaped subshell is yes. The L value is 0. For second question answer, number of ml values for L is equals to 2, that is 5. What are they? -2, -1, 0, +1, +2. For third question, write the symbols of the orbitals. L is equals to 1, that is P orbital, that is Px, Py, Pz. If L is equals to 2, what is the subshell? D subshell. What is the shape? Double dumbbell. How many maximum number of electrons? Means 10 electrons. That is the question and answer. Next, internal choice question is, why does carbon form compounds mainly by covalent bonding? Mainly by covalent bonding. We have to see for this. The same question for internal choice. Why does carbon form compounds mainly by covalent bonding? Carbon forms Why does carbon forms molecules by only covalent bonding? Because yes, answer is carbon. Atomic number 6, electronic configuration. Structure of carbon, there are 4 valency electrons. There are 4 valency electrons. So it was belongs to 4-3A or 14-3A group. So it was belongs to 4-3A or 14-3A group because it contains 4 valency electrons. Okay. Yes. When carbon gain 4 electrons, when carbon gain 4 electrons, it gets stable because carbon has 4 outer shell electrons. If 4 more electrons it was gained, total 8 electrons are there. In any atom outer shell has 8 electrons, it was stable. It will becomes stable element. When carbon gain 4 electrons, it becomes converted into stable. It becomes converted into stable. But in carbon nucleus, means I will say this is the nucleus, K shell, L shell. K to L, how many? 4. 1, 2, 3, 4. If 4 more electrons are gained, total 8 electrons are there. But in the nucleus, the number of protons are not increases. I will say already. Electrons are gained means electrons number only increases, but not the proton number was increases. If only electron number is increases, if electrons are gained, electron number only increases, but not the proton number. The carbon was gained 4 more electrons, it becomes stable, but the proton is inside of the nucleus. The number of protons are there, 6 protons. Total 6 protons. But in the total electrons number, 10 electrons. Outer shell 8 and inner shell 2. Total how many electrons? 10 electrons. So the carbon has not capability to hold 6 protons with 10 electrons or to handle 6 protons with 10 electrons. You understand my point? Carbon has 4 outer shell electrons. Okay. If carbon gain 4 more electrons for getting stability, total how many electrons? 4 plus 2, total 6, and 4 more electrons are gained means total 10 electrons. But the proton number was not increases, even the carbon was gained of 4 electrons. The proton number is the same, that is 6. So the carbon has not capability to hold 6 protons with 10 electrons or to handle 6 protons with 10 electrons. This is highly impossibility. That's why carbon cannot form easily C minus 4 ion. Carbon cannot form easily C minus 4 ion. That's why it cannot get easily and cannot form C minus 4 ion. At the same time, when carbon lose 4 electrons, it forms C plus 4 ion. Third point, when carbon lose 4 electrons, it forms which one? C plus 4 ion. Yes, when carbon lose also gain also, a huge amount of energy was lost by the element. For any process, either losing or gaining of electrons, any element can invest some amount of energy. That's why when carbon lose 4 electrons, it produces C plus 4 ion. But it is also not an easy process, because when carbon lose 4 electrons means it wastes a lot of energy, or it needed a huge amount of energy. That's why it is also highly impossibility. That's why always carbon share the electrons with other atoms or with own atoms to produce the covalent molecules. You remember 2 points in your mind. When carbon gain 4 electrons, it is highly impossibility for the nucleus of carbon to handle the 6 protons with 10 electrons. And when carbon lose the 4 electron means it needed a huge amount of energy. It is also highly impossibility. So carbon cannot form easily C minus 4 ion, and always the carbon was shares the electrons with other atoms or with own atoms to produce the covalent molecule by involving in the covalent bond. This is the answer for this 4 marks question. Last final question. Draw the shapes of S and P orbitals. S orbital shape, spherical shape. Spherical shape. X, Y, Z. Axis theta, X axis, Y axis, Z axis. I have to draw like this spherical shape. Yes, this is a spherical shaped subshell, that is S orbital. Yes, X, Y, Z. X, Y, Z. P orbitals. Dumbbell shape. You remember again in the P3 subshells are there Px, Py, Pz. Now this is X axis, Y axis, Z axis, Y, Z. Somebody they are doing mistakes in this drawing diagram, and Y and Z axis are not mentioned. You must be mentioned the X axis, Y axis, Z axis. Yes, dumbbell shape is on only X axis. This is Px. Next, same X, Y, Z, X, Y, Z. Only on the Y means that is Py, spherical shaped. This is Py. Next, same X, Y, Z, Y, Z, X. Only spherical shaped on the Y, and the Z is Pz. This is Pz. Only on the X means that is Px, the dumbbell shape diagram. The dumbbell shape is on the Y, Py, on the Z, Pz. Total overall P orbitals are Y, Z, 1, 2, and flower shaped diagram, x-axis, y-axis, z-axis. This is all p orbitals. Are you understand here? Yes. Yes, that is all p orbitals. All p orbitals. These are the s orbitals in p orbitals diagram. You must be noted the s orbital shape, spherical shape, then diagram, p orbital shape, dumbbell shape, then px, py, pz, then all p orbitals. You must be notice that one here x axis, y axis, z axis. Symbols also. Without symbol you lose. Yes, this is the total information about the test 1 question paper. Physics part already master explained and me chemistry part was explained. Okay. Yes.